So now let's begin with the agenda for the day. Here, let me start with something on basic things. So the agenda that gets divided goes like machine learning overview. We'll talk about neural networks. What are the industrial applications? We're going to also talk about some of the demos which we are going to use with certain tools which are relevant in the present day industry as a part of SAS offer for machine learning. So these are largely the broad agenda points we have. Meanwhile, anytime in the webinar, if you have any queries, remember this webinar is largely listen to mode. So I would request to type in any specific questions or queries which are there, and we'll reply onto the chat window. So there will be like 2 sessions we plan to reply those chats within today. So halfway through the webinar, I'll also stop for a while and visit the chat window and try to answer some of the query, and the other one we'll do towards the end. Nevertheless, we are going to share an email ID, and onto that email ID you are free to post your queries, and we'll be more than happy to answer that. So these are some of the points I thought before I'll start. Yeah, there is a series of webinar. I think the information should reach you. We have already have timelines and schedules which are worked out. So those series of webinars would be shared to you. Once you are already there, we have your contact details. You will be getting a schedule for these webinars, and time to time you are gonna receive those email IDs. So to begin with, as I said, let's start with something we call as machine learning, and I'll try to keep the terms as easy as possible. The idea is to share the concept across, and then from there we'll move on to the neural networks and their applications. I will do a quick demo, and we'll wrap up the session by taking up queries and discussing what SAS and NGASC, that's Animai's Global Access Pool for Continuing Education, has to offer us together. So that's the overall agenda. So let me begin with, now the term machine learning, you must have been reading across at multiple places. You might have seen it in different areas of advertising or different job positions talking about such kind of terms, but let's try to understand what exactly it is. Well, to begin with, it's a branch of artificial intelligence, and the whole idea of machine learning when it comes to the applications in business is to learn from the data from the past and then try to give out certain decisions. Now, the decisions basically are nothing but predictions done by the machine learning or patterns identified by the machine learning. And it has applications across we're going to talk about in this session. But just remember that computers nowadays are very powerful, and they can learn from the past, the patterns, the history in the data, and based on that, these algorithms have capabilities to project things into the future. That is what our context of machine learning is, or what we understand machine learning as. In fact, in robotics, it's straight away the machine itself learns. You want to make a robot climb a staircase, the robot would drive for first few steps, it might fall, but later on it will adapt to the environment and the robot ultimately climbs the ladder. Now, those kind of definitions do also exist, but they are in the parlance of robotics. We are largely, concentrated here to understand machine learning within the context of business applications. Well, having said that, my machine is computer. Algorithms are the ones which are doing the learning part of it from the past data, and business needs such kind of behavior of machine learning from the past data to streamline a lot of decision. We'll see a portfolio of applications where does this machine learning gets applied, but the concept is simple. Well, moving on, we need to talk these kind of things a little bit more, and then I'll address things, certain things which you might address in the chat window. So moving on with what we have here is machine learning typically allows me to do the prediction better. Now we have seen already, or also we know that statistics has regression equations, and those equations can deliver me the predictions as well. Well, how the industry or the algorithms are moving is to have more and more better predictions, and at the same time, the interpretation part of it, how exactly that the machine algorithm works, or how the business variables are related to my final outcome, that part might be compromised. So there is always a trade-off. Either we talk about predictive accuracy, or we talk about interpretability of the model. So modern machines, they tend to be very complex, or the algorithms tend to be very complex. Business loves them because they're just looking for better predictions. So that thing would always be there. Now, coming to the machine learning, this concept has been there pretty old. So, for example, SAS CEO Jim Goodnight himself developed this K-nearest algorithm, discriminant analysis. That is one of the machine learning algorithms to classify certain items, learning from the past and applying it for the new data or for the future. So it's not a new concept. It has existed, but we see prevalence nowadays for the simple reason that data is now available to the businesses. Powerful computing systems are also now available to be used, and that's where together they can be used to deliver value. So examples are many. In day-to-day life also, you are kind of using machine learning most of the time. You're getting SMSs from the banks to buy a certain kind of loans. A machine learning algorithm would have predicted that giving a loan to such customer is beneficial for the bank. Or you look at Google Apps, it gives you your path, it predicts the time for you to reach your house or to your office. Most of these applications we see, they're touching us today. At the back end, on the Google servers, for example, Google Map, a lot of activity happens. So that's the context. Now, coming to machine learning as it is, the industry requires three things. They need automated solutions, which is what SAS tends to provide. And also at the same time, the data scientists who are working on those algorithms, they want to customize themselves. So SAS technologies provide that customization facility as well. Along with that, obviously, speed is the need of the hour. You need to process the entire data, everything, at or in the required timeline. So if it is too much delayed, if the systems are slow, if the algorithm doesn't converge, that's not what the business wants. So SAS is known for the automation facilities, the customization, and the speed, and that's where the machine learning would make sense. Coming to the literature, there are different kinds of machine learning techniques we can talk about. So the one which does the prediction for me or the classification for me, where I know in the past how the patterns have been or what's my past data, we call it supervised learning. There you have a dependent variable and then you have independent variables, and you kind of try to predict stuff. So that's what we call supervised machine learning, or the other name in the simple language in the business is predictive modeling. Unsupervised learning is simply finding out patterns. So simple things like cluster analysis or Sohm-Cohen kernel density estimation, these are nothing but unsupervised machine learning techniques, and one can mix these two, prediction and classification, along with clustering to get something called as semi-supervised learning. So remember, the machine learning names, the terminologies are used more in terms of supervised, unsupervised, but a statistician or a business guy might know them as predictive or segmentation or clustering. So typically unsupervised learning names are much more popular in simpler terms like segmentation and clustering. Supervised learning is much more popular in the simple business language as predictive modeling, while semi-supervised is a mixture of both. All in all, this can, or all put together, can also be referred to as data mining in certain parts of literature. So that's how these things work. There are different approaches to learning. There are different aspects, different terms can be put onto it, but largely this is what we should know. For machine learning, as we all know it, you need data, computing power, and algorithms. And nowadays, data is available easily. Almost every big organization or even small organization has steady processes to handle saved data. They have the databases defined. Next is to analyze. So you need computing power, which is also not much of a challenge that we have nowadays, given that computers are fast. And the third one is algorithm, and there are a lot of people who are contributing towards this algorithm. So we are sitting at a time of point in the history where all these three things are just in the right mix, And we have now a lot of softwares, a lot of these solutions getting deployed in the industry. So you need at least these three things for machine learning to run. Data, of course, has changed a lot. It's not only the structured data that we used to have, just like row column. We're talking about blogs, online, Twitter, social media data. We're talking about data coming out of sensors. So remember, the data management for machine learning or handling different types of data, including all sorts of big data, it's a separate big area in itself. And there are a lot of job opportunities along with a lot of challenging activities to be done. It's an area in itself. But remember, the data has gone wild, both, as we say in big data, volume, velocity, variety, put onto it value and veracity. 5 V's is what we intend when we talk about data. Then discovery of the data is where your actual machine learning algorithms get applied. It might lead you to better optimization. It might lead you to better predictions, or at the end of the day, better visualizations. In SAS, we tend to call it discovery via machine learning. So that's pretty important, and it's the core part. It's the part where algorithms get applied to the data and final outputs come. So this is the most core of discovery, and that's where most of the creativity of either developing powerful algorithms or applying powerful algorithms to the data happens. Then third, obviously, the business needs it to be deployed, which means the output of whatever machine learning you have done should be made available to simple users who might be a call center guy or a person working in CRM, or it should be displayed on a simple mobile devices or any other kind of devices, or at least the information should go back to the data warehouse so that the business can make use of it. So deployment is yet another important part, and it's another big area where tools are designed around it. Talent and skill set is also sought after it. So once those algorithms are developed, how you deploy in the field so that the benefit comes to the ultimate end user or the business user. So these three Ds, as I would put it, data, discovery, and deployment, are the three hallmarks of the entire process. Now, coming specifically to the machine learning process flow, anywhere when we talk about machine learning, it starts with data. Data often comes in certain formats, shapes, sizes, with problems like missing values and many others. So everything has to be rectified at that place, and we call it data pre-processing. So it could be traditional ETL, it could be high fuel, it could be any other mechanism by which you ensure that data is correct. Then you have to do the feature engineering. Now that's typically when you have your variables coming in the data, you have to see what variables are relevant for your analysis, what might be a good variable to be used in prediction, what other variables can influence that prediction. So all that comes in the feature engineering. Now the feature engineering is a function of statistics and the domain involved. So you need both functional and technical guys at this stage to figure out what variables or what features has to be finally included in your machine learning model. And then comes the learning algorithm, where the data is passed through an algorithm, and that algorithm is the one which will do the job of classification and prediction for us. Within that, we have to evaluate that how good or bad the model is getting evaluated in the entire process. And this process is iterative, and you decide the kind of accuracy which you want. Once everything gets satisfied, your model is validated, evaluated, and when the things are pretty fine, from there we move on to the final deployment of the model, which we call either scoring or classifying. So typically this is what the entire thing goes. Now there are some questions like, from learning algorithm, we need, once the learning algorithm is deployed, you see we have to do the model evaluation. For example, how good the classification is being done, or how good the learning algorithm have been. A quick example could be, let's say you are in a bank and you have the past credit data. There are some defaulters in the bank and there are some non-defaulters in the bank. You apply the algorithm onto it and you check out how good or bad the results are. For example, in the past, in actual, you have 100 defaulters and 900 non-defaulters. Your algorithm should also be predicting the same thing. So that is called model validation or model evaluation. You just cross-check whether the algorithm has learned correctly or not, and that is what is called as model evaluation here. And once you find out that model is accurate enough, then there are other stages, obviously not shown here, like testing of the model. And once you are sure that the algorithm is working fine and then you can just check out and deploy the model. So this is a typical feature over here that you can deploy in machine learning. These are some of the applications that we have. A lot of applications, almost every industry is using it. So be it your next best offers or credit scoring, let's say in banking, fraud detection, customer segmentation in telecom and many other marketing. You must have seen YouTube, Amazon, eBay, which recommends you, or look at the recommender engine, maybe of Amazon. If you're looking for a book, suggestions come up which gives you right kind of suggestions to be, what kind of books you should buy or products you should buy. So those online recommendations are nothing but outcome of machine learning algorithms. Customer lifetime value you have, that you can check it out. Many companies are using those things to predict that or to estimate that. Telecom companies, they are actually worried about the attrition analysis of the customer or customer churn modeling. That's another example. Real-time ad placements, one of the interesting areas wherein you receive ads as and when you move in a retail store. So let's say at the time of lunch, if you are in Shoppers Stop or if you are in a big mall, you start getting ads as and when you move around certain shops. So let's say you're driving and you pass by McDonald's and you receive ads that there is a discount in McDonald's and it's lunchtime. Why not you have your lunch? So all these things are possible because we're sharing data across multiple places, multiple things, and then a machine learning algorithm is giving me suggestions. So you have NLP, cybersecurity. For manufacturing, we have predictive asset maintenance, where we can find out time for failures or what should be the next component failing so that I can prevent it. A lot of these things are happening in there. And while in the course that is Animai is going to run, we are using SAS Enterprise Miner, which is one of the flagship products, and that's the product I'll use for the demo going forward. It has a lot of capabilities. It has UI interface. You can write codes over there. You can do all the other things I was mentioning, including your feature engineering, natural language processing, production scoring, model testing. In fact, using this tool, you can integrate Python and R into it as well. So the tool that we are going to teach in the course that's with NMMIS and SAS, it's the state-of-the-art tool, and it is being used by many corporates. Almost 90% of the Fortune 500 companies are using such kind of tools for their benefit. So we're going to talk that. Now coming to neural network, as I said, this was what we're going to talk about as one of the machine learning techniques. Let's talk about what a neural network is. Interestingly, a neural network, if I talk about a biological neural network, I'm referring to my brain. Well, human brain is something similar to a computer, of course with similarities and dissimilarities. If I have to talk about with similarities, a computer works on silicon transistors, but a brain has got neurons or nerve cells. In fact, we have billions and billions of neural networks. In fact, every human brain, irrespective of caste, creed, religion or anything else or gender, we all have 200 billion neurons and 32 trillion interconnections. Modern day computers are of 1 billion bytes RAM, for example, nowadays we are talking about, and trillions of bytes on the disk. So we can draw parallels. Neuron size is 10 raised to the power minus 6 meter, where you got nanometer transistor size nowadays. Energy consumption is obviously less in the human brain. It is one of the most efficient machines God has created. Kind of half of it what we use, which a present modern day computer would use for operation per second. The difference probably is brain is better in learning, computers are better in storing data and doing the programming capability. But remember, here the brain is one of the wonderful computer machines you have come across. You see, imagine for a moment you can recall songs in your mind, you can recall your past memories, just like videos. You dream and that video doesn't have a voice problem, audio problem, or any kind of flickering problem. So you're storing data on your brain and you are accessing it randomly. The same thing in a computer, the file system, you have to have the algorithms of partitioning the data and then searching maybe on a sequential basis or point basis. So more or less these two things are doing a couple of things which are similar, only with one difference. One has learning, other has programming capability. Now the question is, when it comes to the literature of neural network, why not have the learning capability imported also to the system? And that's where the concepts of artificial intelligence and machine learning was born. It happened quite late in the human history, but then 30s and 40s is what we are talking about when the conceptualization of this thing started, when the computers were thought of, and later on it went on to get developed. So this is the analogy. Now, if I have to define what an artificial neural network is, now any definitions or any dictionary can define it. Typically, it is a computer system modeled on human brain and nervous system. And that neural network is what we're going to talk about today for the large part of this webinar. Well, first we need to understand. I think on the chat window there are some questions. So the energy consumption. You see, our brain needs energy. We need food. We need biological energy. So at the end of the day, every energy that we consume is coming from sun only. So sun gives birth to plants, and plants we eat, the food we eat, and that's how the energy, even computers, the electricity, or the coal, or the fossil, or anything, they're all ultimately coming from the sun. So everything on Earth, I don't know, if you're a physics student, you would appreciate the laws of thermodynamics. One of them says the entropy. Entropy is always increasing, energy is being used. So any thinking process that you're doing in your brain also requires movement of electric charge from one neuron to the other, and that requires energy. So that's the energy we're talking about, 6 to 10 joules per operation per second in the brain. Computers also, whenever you're doing one byte shifting, the information getting update is an operation per second that is happening. And for all of it, again, the computer takes your electricity or the battery life. So both machines, whether brain or computer, has to work for energy. The only thing is energy can come in any shape or any form. So that's the analogy I was talking about. Now coming back, how does the human brain works? Well, so the human brain, if you look at, well, I'll just spend some time on that. The neural network mapping. So I think in the chat window I received a comment that machine takes energy. You see, human brain is the most efficient computer ever created by God. Any other computer that we're creating nowadays, it's not as efficient as what human brain is, but this thing might not be true in the coming future. With the advent of quantum computers and quantum computing, everything gonna change. We would have supercomputers going around in our mobile phones once that technology is established. It is under current lab testing and everything in the lab of MIT, and you can search more on the internet about quantum computers and systems that will revolutionize the entire artificial intelligence and machine learning. But that's something on the future. Coming back to what is artificial neural network, this is what our brain is. Now, typically in our brain, you see we have got layers after layers, and there are cells which process the information, and these cells are connected. Anything you hear, listen, smell, see is nothing but electrical signals interpreted by your brain. Now, it's a famous movie dialogue from the Matrix movie, but it's true. Whatever you perceive as reality, whatever you see, feel, everything is nothing but electric signals being interpreted inside your brain, and the network that does it for you has neurons, which is wherein the processing happens, and some connections which happens through synapse and the dendrites of the cell. So I won't go into the biology, but the system works exactly it is. One of the comments I'm receiving that whether IBM Watson Analytics is a quantum computer, the answer is no. Quantum computer is not a reality, but in labs it is being only tested. You need to tame quantum entanglement theory that was poised by Einstein as a spooky action at a distance or something. So it's a far-fetched thing, but it might come into the reality. None of the corporates or the companies or the institutes have quantum computing right now available to them. It's not quantum computing. So please, see to it that if somebody is claiming to be quantum computing, that would be wrong. Now, coming back to what I was discussing, the brain itself can store information. You see your childhood memories, videos, audios, the movies that you've seen, all inside your brain goes somewhere. And you behave. So what happens is, let's say you see a distant friend coming in and immediately you have a smile on your face or a frown depending on how the memories were. You shake hand with him or you ignore him. So you are receiving input through 6 senses that you have, I think 5 senses. Now they say there are 12 senses obviously. So my input layers are my skin, my nose, my ear, everything else. Everything gets converted into electricity, goes inside my brain. That's where the mixing of that information, processing of that information happens, and my output is something what my behavior or reaction is. Similarly here, coming to the neural network mapping, we try to model the same thing here using machines and then try to predict. So here we are going to talk about the behaviors of learning, behavior of certain items that we see around, and how does the actual neural networks predict. We need to draw parallels, and we need to learn something today on how the neural nets can be deployed, used for solving a business problem. I'm going to give the demo for that. I'm going to introduce the tool for also, so you have to be a little patient once we need to the topic. I received a comment in the chat window that why certain people are dumb. You see, neural network, whether actual brain or artificial, it all depends how you train them, how you stimulate them, and how you ultimately, in the simple language, how you use them. The more you use, the more trained the neural network becomes and more stronger it becomes. So it's all about the environment, the learning, the background, the makeup that decides what would be the final IQ level. Now, which means this, you have to put on the comment why some people are dumb, why some people are not. Given that we all have got same network, same neurons, same connection. You see, God has given same hardware to all of us. It's about the software. It's about how we learn, what environment our childhoods are, what kind of challenges we give to ourselves, how far you learn. An athlete is an athlete because the neural network, he does, let's say, practice maybe 8 hours a day. And that's where the neurons and the corresponding circuits become so strong and he becomes good at it. A mathematician does love mathematics and does practice day in and out. So the whole idea is how and well you use this hardware, your software becomes strong and strong. And what you intend to do it with that. You have a computer, you can play a video game onto it, or you can learn a biology class onto it, or you can do something. So it's about the usage. Well, let's get back to the topic. So here we are. Now, neural networks, when we come, they're very important, and an interesting feature of neural networks is, I don't know if you have known the literature of machine learning or if you have done statistical modeling. Neural networks can do anything. They can be used for supervised learning, they can be used for unsupervised learning, they can also be used for semi-supervised learning, which means anything can be done with that. And they're called as UAs, or universal approximators. And in mathematics, what we have is something called as universal approximator. Now, just to give you an example, what do we mean by it is, if you have heard about Fibonacci series, maybe that was the series we studied in class 12. Some of you might have done it in higher mathematics. You see, Fibonacci series is a sequence of numbers which can describe almost major phenomena in the universe, like spiral of a galaxy, growth of an embryo in the mother's womb, growth of petals, growth of plants, growth of seeds, growth of certain bacterial patterns. This is how your engines are designed when it comes to jet propulsion engines. So the same series is useful at many places in the universe, and it can be fit to explain a lot of phenomena. ARIMA modeling, they can fit almost any series, and they are universal approximator. If you are like an ardent reader, you might have read about golden ratio, that can explain designs of human faces, animal bodies, design of temple, mosques, churches, major buildings around the world. They tend to follow the same ratio called golden ratio. You can read more about it. So such kind of things are universal approximators, and these things can be used for multiple applications. So likewise, my neural nets are also UA algorithms. I can use it for multiple purposes. I can use it for prediction, I can use it for classification, I can use it for clustering, segmentation, and any other of that nature of activity. So that's the utility. Well, where all these neural networks are used. Now these are the major areas. Now if you Google it out also, you will never end up finally consolidating where all neural networks can be used. You see, I've just tried to consolidate it where most of the relevant applications are happening when it comes to SAS clients. So we're using it for academic research, automotive industry, cancer, computer, credit ratings, drug interaction, electric load balancing, financial forecasting, fraud detection. So see, machine controls, marketing, market segmentation, patterns across, robotics, sales forecasting, software security, and whatnot. So the list is very, very long. I can't even do justice by putting these items over there. So, and you yourself should try out this industrial applications of neural networks on Google or business applications of neural networks, and you'll be amazed by the kind of outputs that you get, and you need to spend maybe 2-3 years to at least understand where all these things are being used if you want to be trying to understand it in detail. But that's where the whole idea is. They are so pervasive, almost they touch every industry which has got a reasonable amount of data to be analyzed. I can deploy neural networks over there. To be specific, rather than these were like broad categories, these are some specific usages. So maybe I want to predict the yarn properties in chemical process technology. Typically, when I'm looking at cloth mills, or I'm looking at the new technologies that come up in smart clothing and many other places. We're talking about shipping. We're talking about where to find out oil and gas wells, prediction of that. Marketing dynamics in any other market, whether it is FMCG, durable, or predicting financial markets, their behavior. Specific examples, prediction of newspaper sales, production planning for client specific transformers. We do also use it for shock tuning for automobiles. Typically in manufacturing, if the diagnosis of a spot welding has to be done, where the weld is done, good or bad, this can also be done by using neural network. Remember, the list would be very, very long. Many handwriting recognition algorithms are deploying neural networks. In agriculture, a lot of usages. Banking for credit card fraud detection, neural nets are being used. Water supply management in drinking in US, UK, everywhere the neural nets are being used. A lot of things where we have to use OCR processing for employment trends, information processing, sales order. It could be any application. That's where the neural nets can be deployed. List goes on and on. How much of a Walmart should be selling, what kind of merchandise, that can be done by neural nets for predicting sales, quality control systems, quality assurance systems, lots and lots of things in pharma, manufacturing. I mean, this way, if you see, this list is so long and so long that, I have to stop it somewhere. Many, many things. And indeed, if you just simply search it out, there are a lot of research papers on the Google that are available, how a typical neural network was deployed, what was the outcome and how did it work over there. You just put your area of interest, put your industry, and there is always an application. Now, finance people might ask, what neural network I have to do with that? Your balance sheet predictions can be done. How your balance sheet might going to look like next year, or forecasting of the balance sheet is now being done by neural nets at several places. So you need to check this out. How does it happen? Where does it happen? Market research, churn models, propensity models. If I have to specifically talk about specific applications, which I've seen in India, companies using it. These are some of the areas. So your churn predictions, neural nets are being deployed. Your upsell and cross-sell models at several places our clients are using in India. Neural nets for the same thing. Many other applications in finance they're using. We have a client Delhi-based where the electric forecasts or the power consumption forecast. That's where the neural nets are being deployed. So many applications, many places. Long list of things you will get it. So in fact, doing a justice in 1 hour about applications is not a possibility here. So moving on, what I would do is, rather than going into a very long list of applications, we're going to see how does neural network can be deployed, used, and work. You see, for any predictive kind of thing. So I'll take an example of a predictive modeling problem today. We need to predict the new cases. So that's where I need a neural net. Now, for me, neural net is pretty much simplified. All that glory of comparison with the human brain would boil down to a prediction formula. We'll see neural networks, we need to select useful inputs. So we might have to depend on other techniques to find out what inputs are relevant to my target variable using other different statistical techniques. And ultimately, I have to stop neural networks somewhere. So what happens with neural networks is they keep on training themselves and they become better and better at training data. But remember, I have to do the validation part of it. I have to do the validation testing for the model. That's where I do it. So what is this neural network formula we are talking about? So for me, a neural network is something I want to have a prediction for y. Y could be my business variable of interest. It's a function of h1, h2, and h3. These h1, h2, and h3 are nothing but derived functions from the inputs like x1 and x2. To simplify it, let's assume that you have your age and let's say your qualification, your age is X1, X is your qualification, you want to predict what would be your salary, Y could be salary here, or Y could be sales, X1 could be your advertising spend, and X2 could be your distributor margin. So that way you have an equation to work on. But only thing is, unlike regression analysis where all these input go directly and predict Y, here we are doing activation functions like a tan hyperbolic function onto the linear combinations of all the inputs, and we are putting them in three new columns which are being called as hidden units, or hidden nodes, H1, H2 and H3. If you have a categorical prediction or a classification problem, we are going to use a logistic function, and that's where these input, hidden and target layers would work. Now this is model based on the human brain. So what happens inside our brain, we never know, it's very difficult to understand. But what we know, what was the input and what was the output. So as a human being, I know what I'm listening and accordingly what I should be speaking. Something inside the brain, the thought process, the mixing and all that comes into play, and you have your output ready as the voice. So here also, we call the middle layer as hidden layer because the mathematics goes so complex that we call them black box techniques. We don't understand eventually what exactly the kind of functions and things that are happening, and I can't relate each X1 to each unit of output. So they're difficult to interpret, and sometimes they're called black box techniques, but then they're good at doing the prediction. To give them the input, they give you the output. And what eventually happens is the algorithms that work around these scenes is to start with a random set of W's everywhere, and then in one run the system finds out a set of W's, and the log likelihood function is estimated as in below the slide that I have with me. And within that, the system keeps on iterating, changing the values till the point you get your maximized log likelihood function, and based on that the probabilities are calculated. So that's how the system would work and give me the estimates for that. Now these algorithms are pretty complex. They are written by pioneers in this field. As a user, we are just going to use them without worrying about the exact mechanism, how they work and how they predict. And I need to ensure that I do not have missing values because it's a formula based tool, so I need to ensure in my data I don't have missing values. But other than that, most of the things like outliers, non-numeric inputs, non-linear modeling, everything is generally taken care by the neural network or the way the algorithm we deployed it in this software called SAS Certified Miner. Well, having said that, we'll talk about two examples here. So I'm going to give you a walkthrough of neural network and how to use it using the SAS tool. So I have got two demonstrations with me. So one of them goes like we can start with anywhere, So let me start with, this one. This is a guy called Ted Kaczynski. He's in jail now, and he was one of the youngest PhD holder. He was a mathematical genius. He did a lot of things in his life. Now he's in jail. So this is something on his story, and we'll see where and how this neural networks can be deployed and how we can become the part of this guy. The other demonstration I'm going to give you is about an organic company. So there is a company who want to sell organic products, and they are doing a pilot testing for that, but then they have questions. They want to predict who would buy their product. Within that, they also want to see other business questions like what kind of an advertising strategy they have to adopt for that. Then they also have to find out what are the segments and all that. So there can be many questions which a business can ask, and we'll see how these techniques can answer. So to begin with, what we'll do is, let me, go to the demo part of it and take, one of the stories one by one. So coming to the Ted Kaczynski story, what I'm going to do is quickly show you that if you go to, let's say, simply Google this out. The Wikipedia page will take you there, and if you read about this guy, he's in jail as I told you, and if you read some of the following things, what you get to know that he was a very bright child, youngest to enter Harvard, youngest to enter university, youngest PhD, youngest professor in US, lot of credentials. This is how he used to look like this. But then today, he's in jail and he looks like this. So let us try to understand what happened. Now remember, this guy was a mathematical genius, but at the same time, what happened with him was when he went back to his county after studying in all these big cities, he saw that the nature is being compromised for the developments that are happening. So a Walmart store has destroyed a forest area, then the river was filled with sand, the things are altered. So he never liked the idea. And he is one of the guys who believes in the philosophy of new Luddite. So there is an English term called new Luddite, where the people believe that all this new technology that is coming, it's not for good. Though of course it brings the comfort, but the inner peace is lost. So we are more busy, less happy. Such kind of thoughts he used to have, and then he started writing to many people in US that one should take care of the nature, one should take care of the inner peace, and so much of technological development might not help humanity. Obviously, nobody would believe him. So what he started to do was he started sending bombs to the people, and those who would listen. And this is where you can talk about how to create a bomb in the house or something, but then that's not the context. So FBI has reproduced the way he used to create bombs. So he started killing people, and in fact, all the bombing details are also there on the Wikipedia. What he bombed, what were the losses, what people died, how many total bombs he was throwing. Now, my intention of introducing all this is to bring it down to our software. This is the SAS software that we have. Now we'll start with an issue here. So when this guy was when these bombings were happening, FBI was after him. In fact, FBI took a very long route, took them several years to pinpoint this is the guy, but they had never any proof that this guy is the culprit. So what they did was this guy Ted Kaczynski used to write a lot of manifesto along with the bombing parcel, which was sent separately. It was never handwritten, so it was typed. So police has access to those. In fact, here as a data set, this is what we all teach when we in the course, how to bring on these data sets here and all that. So we have here, his 11 of those essays, but we do not know that whether this was written by him or something. So at least, FBI was in a state that these essays are pretty long ones. I'm showing it on my screen. There are 11 documents. I need to know who is the author. And to do that, remember machine learning, I need to know the historical data. So this Ted Kaczynski was an ardent author, so he has written a lot of articles in the past. So we have his articles going by the author code TK, and there are several other articles that we have written by 6 different authors. So all in all, we have some 1,900 articles or essays written by that guy. By 6 authors, and some of them are TK only. I mean, they were written by Ted Kaczynski. So you see, this is what I called as my training data to begin with, or the past data, where I know for sure who has written what kind of an article. Here I have 11 unknown articles which are found at the bombing sites, but I do not have the original author. Now, one of the questions that I see in the chat window is how is the author code find? You see, this is author code is nothing but a label to the author. Remember, these are known literary works of the people. I know this article was published by this article, so the code is given as DM. So this is something manually or done by the guys who are collecting the data. Remember, this is known authorships of 5 authors, including Ted Kaczynski. Now, this is to start with. To make a machine learn, you should give them historical data where every fact and figure is known. So this is known authorship data. This data is found at the bombing sites where I do not have the author code or the author information. So you do not have that. So it's only what we have is simply the text or the ID, but we do not have the author information. Here from the past data, I know the established authorships. I have coded them. That's my decision. How do I code it? DMM, TK, it's up to you, but it's known authorship. This is unknown bombing site authorships. So I do the partitioning of the data into training and validation, and I have to test that out. So training, validation, test. Now these concepts needs to be taught in detail. In this time, I cannot explain everything, but then let's move on. So I'm deploying text mining capabilities or NLP of the things. I'm using a variable selection to seek out relevant variables. I'm using a neural network node. Now all these are available as nodes, and you can always drag them, make a process flow and do it. So it's a long activity cut short. You have to create process flows like this. There is a sequence and there is an explanation to each of the node in the diagram over here, and that is what we teach typically at length when we're teaching this concept or deploying a project. But now what I'm interested in to see that I have done scoring of these unknown authorship, and when I check the score, I'm doing it via neural network. If I go to the exported data, lot many things the neural network would do is to generate numbers. Somewhere those text will get converted into numbers, that is called text to number conversion. I'll browse for it. You see in the data that I had that I wanted to score, there are a lot of numbers. But remember, these numbers are not useful. Only thing that is useful in the end, I get a column that is prediction for the author. And what I got, that the author is TK in most of the cases, barring one. So 11 out of 10 out of 11 documents, my software finds out that TK or the Ted Kaczynski is the culprit, or he's the one who has written those manifestos and sent along with them. So you see, what is happening here is, if I have to just summarize it very quickly, even human brain can do this. Only thing, if the articles are in millions and we have to find out patterns among several authors, you can't. But your brain can also make sense. Once you read William Wordsworth and let's say Mein Kampf, Adolf Hitler's Mein Kampf, there is always a difference between what those guys are writing in terms of the context, in terms of the sentences, the use of conjunction articles, prepositions, pronouns, all these things. So likewise, my machine and the neural network can also learn the same thing, and then it can do predictions for you. So for example, if I give you 7 essays written by Mahatma Gandhi and let's say 7 essays written by Hitler, and after reading all 4, the next essay I give you, you will be able to make it out whether the writing is coming from Gandhi or from Hitler. You see the style, the different, the language, the way the language constructs are used. Same way your systems can do it for you. Now I can use it for complaint classification. In telecom, I can receive thousands of emails a day, maybe 1 million emails over the years. So to classify which email is what, either I have to put hundreds of people, or I can use a machine learning algorithm which can do the automatic classification for me. The other way is to use it in the organics example I was talking about. So I have the organics data coming from a pilot test. So this is my data. I'll give you an overview of the data here. This is my second demonstration. So you have customer ID, you have all these are called features, by the way, individual variables as a statistician would call it. So what is the gender, what's the region, what's the loyalty status, and ultimately you have a column which talks about what is whether the guy bought the product or not. Now I want to create a learning algorithm out of it that can guide me in the future who will buy the product, who would buy the product. So these are the labels. Remember, this is historical data. We have labeled, we have categorized it, we have put a target column over there as 1, 0. This is all the information known to me previously. I'm partitioning it. I'm running a decision tree model to begin with. Now this answers quite a lot. For example, if I go to the results of a decision tree over here, I get an output and it tells me that you have, if the age is less than 44.5, there is a 52% or 51% chance that people will buy the organic product. As it is in the test pilot data, the 24% are only buying. So which means that if age is less for my customer or for a customer segment, wherein if the age is less and I do not know the cutoff that if it is less than 44.5, my chances of selling the product rises to 52%. Vis-a-vis if I target only the older segment, which is more than 44.55, the chance of selling the product is only 15% or so. So you see what happens is, these things can guide me. For example, now I know if using this analysis or this algorithm that younger ones are the ones who are buying my product more, then if I have to take an advertising decision, I might go with a young personality. So in my slide where I showed Amitabh Bachchan or Praniti Chopra might be a right choice, because my data also says this way, that youth is not buying more products and where my chances are maximized, rather than looking at old personality where my this is not the response. Now in the chat window I received a question saying that what is the source of this data. Now this data is one of our customers' data that we have done a consulting project with it. The customer is not ready to reveal the name, but this data is collected by the systems which are there on that retail store where this pilot test was carried. So there is a CRM system involved, there is a POS system involved or point of sale system involved, and we have to do a lot of data preparation to get this kind of a table. This table we are using, we call it analytical base table, and it has to be made ready by doing a lot of ETL activities and other activities. There is a whole industry around it to get your data ready for analytics. So that's the source of the data. Now I can use a neural net for my predictions, and I can compare which neural net is best. And in future, if I have a list of million customers to me, I can pass on that list of million customer to any of these neural network models, and they can tell me what's the probability that each of the guys would buy. Even right now, if you see, the scoring is being done. Or let me just give you a quick example of how I can deploy the scoring. So I would create a data source. Let me bring in a data where I have a fresh list of customer coming to me. I would call it as score organic. So I'm bringing in the data. You see in this data, I have all the attributes, but I do not know who will buy or who won't buy the product. So I would give it a role of score data, and I would finish the scoring data. I'll bring the data, and if I want to predict who would buy the product or who would not buy the product, imagine this is my future data, these are my future customers. I have made the model based on this data, that's called the training data. This is my new data, the scoring data. So I'm going to run my scoring algorithm based on the best model, which happens to be the neural 2 here that I'll show you. And what you will get is the final score or the final predictions onto the data. So I just want to show you how does it looks like when you score a data based on a neural network. I can show you how the original data probabilities looks like. Now the things are done. I come over here, I go to exported data, I check this out. I simply go to the score data, I browse for it. You see everything else remaining the same as input data, but all I get is in the last I get the probability who would buy the product, who would not buy. So this is predict by 1 and this is predict by 0. So wherever the probability of buying, for example, 4th row, the probability of buying is 91%. So these are the guys whom my product offer should go, or the advertisement should go, or the recommender engine should tell this guy that buy my product. And the chances of selling to this guy is 91%. You see these probabilities, all I get is by using neural nets. So these are some of the two demos. Remember, these applications are endless in neural networks. So be it your organic retail kind of a thing, be it your financial prediction. Example of this university bomber, Ted Kaczynski, is called forensic linguistics. So I've just tried to flavor of things. And this was just a question I thought I'll ask, but then let's skip it up. Neural networks are universal approximators. So let me just skip it for a while. And the slides are a little bit going left and right. So the right things about neural network in enterprise miner are these are universal networks, and they can't select inputs. You need other methods. Now C and D are wrong in this one because for the simple reason that neural networks are very difficult to interpret, and some industries, some regulators don't want you to use neural networks. They doesn't recommend because it is very difficult. D is correct in the sense that neural networks can model nonlinear relationships, and they're pretty useful for that. So that is something we have it. So in neural network, what happens? This logic gets calculated. You give the initial value, random values, and your system iterates. So on the training data, it keeps on building the training model, and on the validation, it keeps on building the validation model, and the model which is least error in validation is all picked up, and that is finally used for your scoring. So these iteration plots can also be seen. The logic is simple. If I go to, let's say, this neural net, for example, if I go to the results, so this will tell me which model was the best. So here in the output, you can see that I started training the neural network. It went ahead till 40 training or so. After that, both my errors become stable. My validation error is least at the 12th iteration, and that is the 11th iteration, sorry, as the number is 11, you can see over here in my screen. And that is what the set of equations is being used by to finally predict the probabilities who will buy the product, who won't buy the product. You can check this neural 2 also for that purpose. We're using a decision tree to filter inputs to the neural network here. So that is the fine shades of discussions happen when we do it in depth when we are running a course. So right now this is what we have done with some demos. So we have predicted probabilities who will buy the organic product. We'll also done forensic linguistics, wherein we predicted who is the author of all those manifestos which were sent across with the bomb. So now I'll spend some time to few things like this course, we have started with NGEST, which teaches you machine learning in much more detail, and there is a full course around it. So this is a small history. NMMIS has been there for a very long time, part of SVKM, and that ways I got, it has prestige, it's its own prestige when it comes to teaching. SAS has been a leader across when it comes to providing tools and technologies in machine learning. So both work together to offer you the best course. And here we see that SAS and NMMIS partnership is also old. 2011 it became NMMIS becomes client. Later on we have been jointly doing a lot of activities, data mining championships, workshops, MDP programs, many other things that we are doing. And NMMIS is one of the prestigious information institution to have a highest number of SAS certified faculty, SAS certified students, and what we're doing with Global Access School for Continuing Education is just one more step to serve the society better by deploying these advanced knowledge and advanced techniques in the distance mode as well. So that is what we have started off late, and that's the results you see. There are two programs that we are running right now. One is management program in data visualization, which comes automatically with a coverage of business statistics for 24 hours, 2-hour sessions per day, 1 month, and visual analytics for 3 months, 32 hours, 2 hours per session. And then we are also offering SAS Global Certification along with that. So overall is 5 months, and this will include everything: lecture, practice sessions, exam, and global certification. And on the same lines, we are also offering big data and machine learning. That's predictive modeling as we call it. So here also we have initial knowledge. Some of you are mentioning I don't have any initial knowledge, so we'll take care of that. We'll teach first the basic business statistics course. We'll give a bridge course also. Then we'll move to machine learning and other topics. There also we are covering specific case studies on finance, let's say financial risk management, marketing analytics, operations, and supply chain analytics. So this entire course is around 7 months, and it includes everything: lecture, practice sessions, books, exams, and global certification from SAS. So that's the program structure that we have for this. And this program with NMMIS, why, the SAS, of course, we are good in technology, and we have been delivering technology to best of the companies across the world. But when it comes to education, MMIS has its own strength. NMMIS provides business statistics courses, bridge courses. It provides a lot of other things that can help from many perspectives to a budding student. So a joint combination is always the good. So SAS provides 24/7 SAS software, its own global material certification, and the rest of the things comes from NMMIS. It's a win-win situation that we have. So here I would stop, and if there are any more queries, you please be putting into the chat window. And again, you just check out, write to this email ID that I'm showcasing here. Please make a note of it. And this is a toll-free number wherein you can give a call from Monday to Saturday, starting from 10 a.m. in the morning to 6 p.m. So please feel free to write to us, and please write also in the chat window. So I'll be quickly navigating through my chat window and trying to address some of the questions that I'm getting in the chat window. So let me start with that. Meanwhile, you make a note of the email ID. Please write everything, even you feel like whether I'm suitable for this course or not. We have a very good team of counselors that's going to help you. That's the email ID and the phone number. Now, a few questions I got in the chat window. Can a commerce student with no knowledge do it? The answer is yes. We have in the School of Commerce of NMMIS some of the best people who were trained on machine learning. So it's about the interest that you develop. But do speak to counselors. A commerce student might have to take up a business visualization course first and then move on to machine learning. So there are, things. Some of you are asking for the fee details. So please write to this email ID or call the number for everything else, the fee details and all that. This webinar is not going to discuss the fee details or any other stuff. So please write to the email ID. Now there are some more questions that we are getting. Is people there are SAS users of SAS macros, and they want to explore machine learning and stats. How do I start it? So this course is, I think, the right course to start with. Then there are other questions. Can we use text and speech recognition? Yes, both can be used for that. And speech recognition also is like, changing those speech to numbers and then analyzing it. SAS Via and other SAS tools are there to do all those things. So possibilities are limitless. And then, there are some questions I think that I've been answering while the webinar was watched, so I don't know any questions that are remaining. You will get the recordings any which ways. I think you will be receiving mails, and you will receive mails post this webinar also in the next week, and that will talk about how the recording has to be shared across. So any questions regarding the cost or your profile? You might be an engineer, you might be a commerce guy, you might be an architect working for several years, and now you want to do this course. Please feel free to write. We will deal with it case to case basis. We can't answer at one shot in a webinar like this. So we'll go one by one, case to case basis. Detailed discussions and conversations are required to discuss your profile and then find out the fitment and the suitability of the profile to the course. So that is what we are gonna do. So I'll stop here, and if any more queries, guys, please feel free to write to the email ID and the phone number that we have here.